And welcome to this episode of Microsafaris featuring Spirostomum, or what I like to call snakes on a slide. As you see these guys, they clearly look a lot like snakes, albeit much, much smaller. A lot of people will also see them under the scope and say they look a lot like worms, and that's what a lot of my students think they are the first time they see them. But they are actually microscopic single-celled organisms. They belong to a group called Ciliates. As you'll see later, they have cilia with which they use to swim and feed, but they are a fascinating creature with a bit of an image problem, and we're going to try and take care of that here today by taking a closer look. As you look at these Spirostomum, one of the first things that comes across is that they are large for a single-celled creature. They come in here at just over 1 millimeter in size, which is small for Spirostomum. Some of them will get up to over 4 millimeters in size. And what they're doing here is they're venturing amongst the bacterial mats here trying to feed. They are what we call bacteriivores. They feed almost exclusively on bacteria, which they sweep into their mouths through their cilia. Another cool feature of these guys are these stripes that run down them. And the stripes are actually myonemes, or like muscle fibers, that allow them to contract faster than any other known cell. Spirostomum can contract to 25% of their length in less than 10 milliseconds. Pretty amazing. Another really cool feature of Spirostomum you see here, and it's not easy to see frequently, but this chain of beads are actually the nuclei. Most single-cell creatures have one kind of circular nucleus with all the DNA in it. But for some reason, Spirostomum, perhaps because they're so long, have this long bead-like series of nuclei. It's not well understood why this happens. The only other species I know of it happening in is Stentor. And here, as it moves around a little bit, you can actually see some of those beads as I shift focus back and forth. There they are very clearly. You really get a good feel for it. But it is one of the great mysteries of this particular species. As we continue along here, you'll notice some of the contractions that are going on, and that's because of those myonemes, those stripes. It's nice to be able to see it up close like this at high power, because you get some sense of what's going on inside. But I will encourage you, take a close peek around the edges, and at times when the light hits just right, you'll be able to see the cilia beating. It's covered in rows of cilia, and again, as I said earlier, that helps it swim. It also will help it with feeding. The light area you see up at the top there is one of the contractile vacuoles. It helps to control water balance so that this thing doesn't fill up with water more than it should. It's able to get rid of it, and you get some sense of the other food vacuoles, the lighter spots outside of the nuclei, where it will keep batches of bacteria. I like in this area you can see how it twists and turns, so it has the ability to twist around and move itself. There you see a great view of the nuclei very clearly as I play with the focus. So I hope this gives you a hint that this is really a much more interesting creature than you may have first thought. Thanks for watching, and thanks for our friends over at Exo Labs for their great focus microscope camera. And feel free to find me online at Twitter at BlueLionPhotos or BlueLionPhotos.com. Thanks.